AP students. I thought I would do a live problem-solving demo of this homework from a little while ago, which was finding pairs of amicable numbers. So I've gone ahead and I've pasted the homework assignment here as a comment. So just to review, amicable numbers, it says, are two different numbers that are the sum of each other's proper divisors. Okay, and then I explain what that is, and then I have a pair, and I sort of explain how that makes sense. So it says, write a method that takes two integers as parameters and returns true if they're an amicable pair and false otherwise. Okay, so public static, it sounds like it's going to return a Boolean, and I'm going to name it areAmicable, and it takes two ints, which I will call A and B as inputs. I'm just going to return false temporarily so that there aren't any compile time errors. Yeah, let's just go ahead and start writing this one. So it says two numbers are amicable if, what did it say? They are the sum of each other's proper divisors. Okay, so I'm going to make a new int called sum of A, which is the sum of divisors of A, and sum of B is going to be sum of divisors of B. And then I'm going to check, well, so I could do this. areAmicable is true if B equals the sum of A's divisors, and also A equals the sum of B's divisors. So those are my two tests. So I could perform these two tests. If they're both true, I save the result into areAmicable, and then I could return areAmicable. Or I could just return the results of these tests directly, which is what I think I will do. Okay, cool. So notice I have this sneaking suspicion that when some of you write code, you just write all of the logic at once. But see how like the fundamental operation here was calculating the sum of the divisors, and we do that more than once. So it makes sense to chunk it out as its own method here. I'm worried that you're not doing this. You're not looking out for opportunities to chunk it out, but this is what makes good reusable code. It also makes your code a lot easier to debug, because if there's a problem, now I can test separately. Is the problem that I'm calculating the divisors wrong, or is the problem that this test is wrong? So making more methods that are independent of each other makes it easier to debug because you can debug them separately. Okay, so I'm going to make sum of divisors now. So sum of divisors int num. Okay, so in this case, I'll start out with a sum variable. Let's see, did it say proper divisors? So I'm wondering, do I include the number 1? And it looks like yes, but I don't include the number itself. Okay, fine. So I'm going to do this in a way that is not optimizing for efficiency, and I'm only going to come back to make it more efficient if I need to. So I'm going to start I at 1, and I'm going to make I go all the way up to num. And I'm going to say if when you divide num by I, the remainder equals 0, that means we've found a divisor. So I will say sum equals sum plus I. And then at the end, I will return sum. Okay, just to make sure this works, look, I've given you this nice example of what the answers should be. So let's just run it really quick and make sure it actually works. So system.out.println. So the proper divisors of 220 are a bunch of stuff, and the total sum is 284. So let's run that to make sure it works. So sum of divisors of 220, and now when I run it, I would expect that to output 284. Great. And now let's run 284. Great, 220. Okay, this is another thing that I'm worried that some of you are not doing, is you're not testing as you go. I think if you're not testing as you go, you are taking an incredible gamble. Okay, so far so good. We've got this one, areAmicable. So I guess we're ready to test areAmicable as well, because we made sure sum of divisors works, or at least we tested it with a couple of numbers. We didn't test it with edge cases yet, but I'm not worried about that right now. So let's test if areAmicable is true when we give it 220 and 284, because we would expect this to return true, because I told you they're true and we just looked at it. So this says true, great. So let's change one of the numbers and make sure it returns false. Cool, false. Okay, so again, this isn't a guarantee, just because it worked for this example is not a guarantee that it's going to work for all possible examples, but I am more confident now that this is probably a correct solution. All right, so now use your method to search all pairs of numbers less than something large and display any amicable pairs you find. Okay, so I'm going to make a method for this as well. I guess I'm going to make it void. Find amicable pairs. And I'm going to make it says search up to some large number, but I'm just going to make that number a parameter for my method. So I'm looking for pairs of them, right? So let's, in the spirit of brute force, I'm going to loop over all possibilities. And I'm going to loop over a whole bunch of values for A and a whole bunch of values for B. So I want a nested loop, 2 nested loops. So number A is going to start at 1, and then A is less than max, and then A++. And then for int B starts at 1, and B is less than max, and then B++. And then if are amicable, A and B, then I will print the pair of them. So I'll print A, and then, oops, and then B, and then I will print a heart, because they're so amicable. All right, so let's run find amicable pairs now. And I'm not going to run it with such a large number to start with. I'm going to run it with 1,000, because we know we should find at least these two. Okay, so I'm finding 6 and 6 and 28 and 28, but does it say to find pairs that are different from each other? I think whether or not it says to, I think maybe it's strongly implied that they should be different from one another. Although I guess maybe not. I mean, 6 and 28 are special numbers. They're called perfect numbers because they are equal to the sum of their divisors. So maybe it's worthwhile to print out pairs of perfect numbers. Okay, so we're finding this one twice, and then we're finding this one, so 496 presumably is a perfect number as well. Let's fix this. I don't want to find pairs twice, so I'm going to start B at A instead of starting it at 1, so that way I won't find the version where A and B are just switched. And let's run it one more time. Great, that looks good. So I'm going to bump it up now. Let's run it again. Okay, this is super slow. So now that it's super slow, I feel like I want to go back and figure out how I can speed it up a bit. So, well, first let me say before we do this, what I've written here I would consider to be a perfectly fine solution to the problem if I gave it on the quiz. Some of you are writing things that are not this clean. So find amicable pair. You're doing all kinds of weird while loops and if statements and other things. I want just very direct, very simple using methods. So if you're not doing that right now, this is something important to practice. What I'm about to show you is what I would consider sort of a little bit beyond what I'd expect. So sum of divisors. Some of you actually did this, but if you think about the divisors, if the number I divides num evenly, then whatever the result of the division is would also be another divisor. So actually, I don't need to loop all the way up to num. I only need to loop up as far as the square root of num. So I could say math.square root num here. But remember, calculating square roots is a little bit slow. So I'm going to say I times I is less than or equal to num. And now if I find a divisor, I'm not only going to add in I, but I'm also going to add in what's the result of num divided by I. And I know that this is going to be, I know this is safely an integer here because we've just established in the if statement that it divides it evenly. So now I'm adding, so now I've essentially cut the number of loops I'm doing way down, and I'm adding 2 divisors at one time. Let's go back and make sure that this hasn't broken anything. So I'm going to, again, just search up to 1,000 and make sure it finds all the things it's supposed to find. Oop, I have broken it. Now it doesn't find anything. I bet I know what's happening. So here I start I at 1, and when I divide by 1, the other thing that I'll be adding is the number itself. But remember, we decided that that was not one of the divisors we wanted to count. So I'm going to start at 2, and then my sum is going to start at 1 since I'm assuming that 1 is a divisor of all numbers. So I'm not actually testing for 1, I'm already including it in the sum. Okay, let's see if that has fixed things. Great. And I hope you noticed that that went a heck of a lot faster. So let's try and add a couple more zeros now. See what that does for us. So it's still not the fastest in the world, but you can definitely tell that there was a speed increase here. I think I'm going to leave it here for the moment because the important part for my problem here wasn't that we come up with a clever, efficient solution. I just want to see that you can write a clean decomposition of the problem, of a brute force solution to the problem. Okay, good luck. I hope this has helped you and that you'll do well on the quiz.